Okay, I am sorry that this episode is a bit late. Other things have gotten in between, but now we are here. And in this episode we will add a feeling of perspective to our walking character.
The principle is quite simple, and the effect is rather nice.
The further away the character is, the smaller will the representation be on the screen. The lower the y value is, the further away the character is. So to do this we need to be able to change the size of the image that is the sprite. Different systems for rendering images in a computer game can have different ways to do this. So in this serial I am using ct.js, which is based on JavaScript and the Pixie.js library. This episode is based on earlier episodes in this serial. To understand this episode fully, you might need to see those earlier episodes first. Looking at the documentation for the ct.js, there seems to be a scale function that should work to scale an object. Unfortunately, however, this scale does not seem to work. However, this scale x and this scale y does work. So we can use that. 1 is the original size of the sprite. Factors between 1 and 0 will scale down the image. Factors above 1 scales up the image. Negative factors will flip the image. I will make a variable for the scale in the template. I will call it scala, as it will be used by copies, objects, using the template. It will be this scala. At the creation of an object, I set this scala to 1. Under frame start, we will set the value for this scala for this frame based on the sprite's y position in this frame. We start with the factor where the sprite is at its smallest. So we have limits for how high and how low the character can walk. 115 is the highest, and 462 is the lowest. And by highest means how high up in the screen the character is, and lowest is how low in the screen it is. So the y factor is larger when the character is lower in the screen.
Let's say that the lowest scale factor is 0.6 and the highest is 0.9. So we start with the factor 0.6 and then add to the factor for the distance in the y direction from the lowest distance, 115. So this y minus 115, and take this times the difference of factor for each added pixel in the y direction. The difference for the whole distance is 0.9 minus 0.6, which equals 0.3, and the number of pixels is 462 minus 115, which equals 347. So the difference for each pixel is 0.3 divided by 347. So when we set this scala, we can use that to set this scale x and this scale y, and that is what will set the size of the sprite. Finally, we use this scala to adjust the point at the character's feet to check if the character's feet is inside the box. And that is pretty much it. We can now check if the code works and if the result looks good. And I think this looks pretty good. If the perspective illusion don't look good to you,
You can toggle the high and low value around until you are satisfied with the result. In this case, I am using this X and this Y, which is the top left corner, rather than the position at the feet. The position at the feet would have a lot of advantages. But I'm trying out this thing where I am using the default position. The result of this is that the direction that the character will move will be different from the direction that this direction is set to. In this case, that doesn't really matter. The direction is random within certain parameters, and the differences are not large. This does, however, indicate that my choice in an early episode to keep the sprite's axis at the top left corner, the default setting, instead of setting it at the character's feet, might not have been the best choice if we need a more exact control over the direction that the character moves in. So, we tried this out and I think it looks quite okay. Perspective illusion works fine, well, in my opinion. To complete the illusion, we would need a background drawn in perspective and adjust the largest and smallest size of the sprite to fit with the perspective of the background. One thing that does not work well at this point, at least not as well as it could be, is the turning back when exiting the box. At times the character hovers at the border. This is because the character in some cases is not moving back inside the box, and instead of keep moving in the new direction, again flips direction to move outside the box. The move to previous position is not enough to move the character inside the box at all times. To fix this, I change the code for the bounce. I do a bounce rule for each of the borders. The bounce will be random between 45 and 135 degrees, where the borders are set on the 0 to 180 axis. The character will now always be directed into the box, even if it does not get into the box at the first frame. This will be a bit more code, but it's more reliable and really not that much code. And yeah, there we are. And well, this will be all for this episode. An additional thing I want to do is to add more Draugr objects walking inside the box. There are at least 2 questions connected with this: collisions between the objects and rendering the object closer to the viewer on top of an object further away. But that will have to wait until a later episode. I hope to see you then, and for now, bye.